Now we move on to the next exercise of the equation of line. Now this particular exercise is based on inclination, or we called it in a simple words as slope. So that's inclination or slope. So we can see that whenever this is the x-axis and y-axis, or x-axis and y-axis, if any particular line is going to make something like this, then this is the angle what it is making with the x-axis. So this is the x-axis. So the angle which the line, this particular line, makes with the x-axis is called as the inclination. So in this case, the inclination over here is positive in nature, right? Now, if the thing is like this, if it is going to be like this, then the inclination over here, this is minus theta. So this is negative inclination. In such case, we can also take this as the inclination. So this is the inclination and this is positive inclination and this is the negative inclination. So if I am taking the arm of the angle to be the negative side, if I am taking it towards the negative, if this arm is towards the negative, then the inclination is negative. If the arm is towards the positive, the inclination is positive. Here, this is towards positive, so inclination is positive. If I take this angle over here, it is negative theta. So that's the inclination, positive and negative. We can also see that the inclination over here, so when we see this inclination, the inclination is, suppose we take this way, then this is theta, right? I can find out the slope. Now what is the slope? Slope is equals to, we take it as m, the letter m is denoted as the slope, and we take the slope to be as nothing but the, if I take this line, so this is the slope we are talking about. So this slope is represented by, suppose if this is the height and this is the base. So we are talking about this particular line. So you can see this line over here is nothing but the vertical rise upon the horizontal rise. Okay, you can see the slope is given as this y upon x. Okay, it is nothing but vertical upon horizontal. And you can see if I draw this as a triangle and this is a right angle triangle, then what is this y upon x? Y upon x is nothing but tan theta. So tan theta is equals to y upon x. Therefore, slope m is equals to tan theta. So the first thing is that slope is given by the formula tan theta. Tan is opposite upon adjacent. Opposite upon adjacent. Got it? So tan theta is opposite side upon adjacent side. Got it? That is tan theta. Again we see that, so if it is, say, let it is 45, then slope m is equals to tan 45 is equals to 1. If it is, suppose the line is this way and this is 45, then it will be negative 45. So tan is equals to tan minus 45 is equals to minus 1. Okay, so tan will be this way, that tan theta, this is because it is minus tan 45, therefore it's minus 1. So if it is negative, then there will be a negative sign to that thing, and if it is positive, it's the same value in a positive form. So the difference between tan ka value positive and negative is the sign itself. If it is a negative, if the inclination is negative, then we take a negative sign, and if inclination is positive, then we take a positive slope. So the slope will be positive for positive inclination and slope will be negative for negative inclination. right? So that is positive slope, positive inclination, negative slope, negative inclination, and vice versa, right? So tan 45 है तो 1 है, but tan 45 अगर इस तरह से है with the negative axis, that will be -1. The next one we see is, suppose I take this particular point as, and this particular point. Okay, I take these 2 points over here, or let us take another diagram altogether. I have taken this x-axis, and this is y-axis. There is a line over here like this, okay, and we take 2 points, 1 point here and 1 point here. This point over here is P, which is x1, y1. This over here is Q, x2, y2. So if I draw a line like this and a line like this, we know that this angle over here is theta. So this angle over here will be theta. So tan theta, we know over here that tan theta will be equal to this distance upon this distance. So what is this distance? It is nothing but this is over here y2 and this over here is y1. So this is nothing but y2 minus y1. So it is y2 minus y1. What is this? This part over here is x1. This part over here is x2. So the distance between these 2 points is nothing but x2 minus x1. So that is upon x2 minus x1. This gives us the formula for the slope as slope is equals to tan theta is equals to y2 minus y1 upon x2 minus x1. So this is the slope formula, that slope m. Slope is given by the letter m, which is equals to tan theta. If I know the angle, I can directly take the value of tan theta for that particular line and take it as a slope. If I don't know the value of tan theta, then I will be given 2 points of that line. Okay, if I am given 2 points of the line, I can take the 2 points x1 and y1 and x2 and y2 as the 2 points and find out y2 minus y1 upon x2 minus x1 and get the slope of the given line. Okay. Now it is seen that, suppose, let's take it now let's take it one by one. Suppose this is the x-axis and this is the y-axis, and if I got a line like this at an angle over here 60 degrees, so this slope will be equal to tan 60. This is tan 60, and there is another line parallel to it. So this angle will also be 60. So what is the slope? Again tan 60. So you can see, if the 2 lines are parallel to each other, their slopes are equal. Okay, so what is the next thing over here? Parallel lines, if the lines are parallel, M1 is equals to M2. What is the inference? We conclude that over here, because they are parallel lines, so the inclination with the x-axis will also be the same in both the cases. If one line is inclined to the x-axis at 60 degrees, the parallel line will also be inclined to the x-axis at 60 degrees. Accordingly, both of them will have the same slope because slope is tan 60. So the slope of this line will be equal to the slope of this line. So in parallel lines, the slopes are equal. What is it? The parallel lines, the slopes are equal. We move on to the next thing, and if it is, suppose we don't have this line, but now we have a line which is perpendicular to this line. Means यहाँ पे perpendicular, this perpendicular. Then what would happen? What would happen? See this. This is 90. Because it's perpendicular. This is 60. So what is this angle? 30 degrees. Right? Automatically this angle will become 30 degrees because this is over here. So if this is 30 degrees, then automatically over here, this particular part over here will be how much? It will be 150 degrees. And what is 150 degrees? 150 is nothing but 90 plus 60. Okay. So over here, you see that it will be this way, that this angle over here, this particular theta over here, what will be formed over here, theta, this is, I'll just write it once again. This angle over here will be 150, right? What is 150? 150 is theta, and the theta is nothing but 90 plus 60. This was 60. So we have here theta is equals to 90 plus, or we can say this as alpha, So that is tan theta is equals to tan 90 plus alpha. Okay. So it is one particular rule is there, that is tan 90 plus alpha is equals to minus cot alpha. Okay. Hence what will happen? You can find that over here this becomes, so this particular thing is, let's take up it in this part, is tan theta is equals to minus 1 upon 10 alpha. Tan theta is 90 plus alpha. Tan theta is equals to minus cot is nothing 1 upon 10, right? So if I bring it over here, what will happen? It will be tan theta into tan alpha is equals to minus 1. What is tan theta? That is slope 2. What is tan alpha? Slope 1. So that's why we get m1 into m2 is equals to minus 1. This is an important result. Formula. So what is the formula here? I'll just erase this, or I'll just retain it and write the important formulas of this particular part. First one, m is equals to tan theta is equals to y2 minus y1 upon x2 minus x1. Next is parallel lines. Parallel lines, in case of parallel lines, what happens? m1 is equals to m2, slopes are equal. And in perpendicular lines, perpendicular lines, it is found that m1 into m2 is equals to minus 1. Or we can say that m2 is equals to negative reciprocal of m1. Okay, why? It is m2 is equals to minus 1 upon m1. So that is why it is m2 is negative reciprocal of m1. So if m1 is equals to 1 upon 3, m2 will be equal to minus 3. If m1 is equals to minus 4, m2 will be equal to 1 upon 4. Negative reciprocal. Understood? So these are the main things about the formulas to be used in this particular part of the exercise. Okay. So yeah, one more thing is condition for collinear. So when will I say that the 3 points are collinear? If the slope of AB, so if I say that 3 points are there, if there are 3 points, if there are 3 points over here, A, B, C, so how do I know that they are collinear? If here slope M1, here I get slope M2. If M1 is equals to M2 and if B is a common point, then automatically it's collinear. So this is collinear. Okay. So for the 3 points to be collinear, the slope of the 2 lines AB and BC should be equal. If they are equal, then they are collinear. So that's the condition of the collinearity of 3 points. Right, so that was about the formula. We now move on to the exercise 14b. First, we do the alternate sums of 1, 2, 3, 4, 5. Question 1, exercise 14b. Find the slope of the line whose inclination is. So, first one is 0 degrees. So, tan 0 is equals to 0. Therefore, m is equals to 0. Third one, it's 72 degrees and 30 minutes. Okay, for this you need to find out from the thing which is given in the backside. On the backside they are given you certain values of tan and all which we can take out. So that is, I'll just show you. This is the natural tangents is what is there on page 454. You can have, maybe with the book it may change from here and here. This is an older version, so the new book may have 1 or 2 pages here and there. The above is natural tangents. So you just need to find out the tan 72 degrees 30 minutes. So that value you can find out over here. You can see here at this up to 44. So the next page is up to 90. So we need to find out 72, and then in under 30 minutes, there's 0, 6, 12, 18, 24, 30. In multiple of 6, they are written the minutes. So under 30 and 72 over here, you get the value as 3.1716. It's 3.1716. That's the value of tan theta. So tan 72 degrees 30 minutes is given to as 3.1716. So that's the value of m. M is equals to 3.1716. Okay. The next is, you can also have this in the log table book. The log table book also has the natural tangents in it. So yeah, you can use that one. The second one is, first is, right, the second one is find the inclination of the angle whose slope is 0. I'll take the second and the third sum. So inclination is root 3. So it is given that m is equals to tan theta is equals to root 3. But you know that root 3 is for what particular thing? It is root 3 tan. What is root 3? Tan 60. See, tan 60 is equals to root 3. Therefore theta is equals to 60 degrees. Okay, so that is theta is 60 degrees. The next is 1.0875. It is m is equals to 1.0875. So tan theta is equals to 1.0875. So again you need to find out theta. So again this is from the table. So we again see the table over here. So table of tan, yeah. In the table of tan, I am going to look for 1 point. So here it is, everything is 0 point something, but on the next page is 1 point. I want 1.0875. 1.0875. Yeah, it is 47.24. Okay, it is 47 May under 24 minutes. It's 0.875. So it is 1.0875 is 47 degrees 24 minutes. So it's for tan 47 degrees 24 minutes is equals to 1.0875. Therefore theta is equals to 47 degrees 24 minutes. Clear? That's sum number second. We now move on to sum number 3. Sum number 3, the first one, you have got the values of the 2 points as -2, -3, and the next one is 1, 2. So we have the value m is equals to y2 minus y1 upon x2 minus x1. This is my x1, y1, this is my x2, y2. This gives me 2 minus of minus 3 upon 1 minus of minus 2. That gives me 5 plus 3. 5 upon 3, so m is 5 upon 3. We move on to sum number 3. It is a comma minus b, and next is b comma minus a. This is x1, y1, x2, y2. So again we have m is equals to y2 minus y1 upon x2 minus x1. y2 is minus a minus b, minus of minus b, upon it is b minus a. So this gives me as minus a plus b upon minus b, sorry, this will be minus a plus b is equals to 1. This is minus a plus b, so again both are same, so it is 1. So m is equals to 1. That was sum number 3 ka 3, right? The next one is sum number 4 ka first. Sum number 4. Find the slope of the line parallel to AB if A is minus 2, 4. So it's given that A is minus 2, 4. And B is given to me as 0, 6. So we know slope m1 will be equal to y2 minus y1 upon x2 minus x1. That will be 6 minus 4 upon 0 minus minus 2. That will be 2 upon 2 is equals to 1. Now you know that you need to find out the slope of a line parallel to this. So we know for parallel lines m1 is equals to m2, therefore m2 is equals to 1. Got it? So that's the first thing, and m2 will be equal to 1 because m1 and m2 are going to be the same in case of parallel lines. Right? So we now move on to sum number 5 first. Sum number 5, 1. Find the slope of a line perpendicular to AB where A is given as 0, minus 5 and B is given as minus 2, 4. So first slope AB is m1 is y2 minus y1 upon x2 minus x1 is 4 minus of minus 5 upon minus 2 minus 0. So that will give me as 9 upon minus 2. Okay. So we have m1 as this. Now for perpendicular lines, we know that m1 into m2 is equals to minus 1. So m2 is equals to, or we can say right over here, 9 upon minus 2 into m2 is equals to minus 1. So m2 is equals to minus 1 into minus 2 upon 9 is equals to 2 upon 9. So that gives me m2 is equals to 2 upon 9 as the required answer for question number 5 first. Right? So section number 4 was 1 and question number 5, 1 is 2 upon 9. Okay, we move on now to sum number 6. Okay, sum number 6, here it goes. The line passing through 0, 2 and minus 3, 1 is parallel to the line passing through minus 1, 5 and 4, a. Find a. So you got one is 0, 2 and minus 3, minus 1 parallel to parallel to, it is -1 5 and 4 comma a. So there is इसका slope और इसका slope same होगा because they both lines are parallel to each other. The line which is passing through this point and this point and the other passing through this point and this point, both are parallel to each other. So first of all we'll find out m1. m1 will be equal to y2 minus y1 upon x2 minus x1. That will be -1 -2 upon -3 minus 0. So that will be -3 upon -3 is equals to 1. So m1 is equals to 1. m2 is equals to a minus 5 upon 4 minus of minus 1. That is a minus 5 upon 5. Now it is given that for parallel lines m1 is equals to m2. Therefore 1 is equals to a minus 5 upon 5. So 5 is equals to a minus 5. A is equals to 10. Got it? They are given as that they are parallel lines. So because they are parallel lines, therefore they will be same slopes. Hence A will be equal to 10. Clear? We move on to sum number 8. Sum number 8. Without using the distance formula, show that point A, B and C are vertices of a right angle triangle. Now, how can the 3 points, you get 3 points, you are given the 3 points over here, 1, 2 and 3. They are given this point over here, A is 4, comma minus 2. You got B over here, which is given a minus 4, 4. Now, and the last one is C, which is 10 comma 0, 10 comma 6, sorry. Now, I don't know whether this is 90, this is 90, this is 90. I don't know this thing, so I cannot actually draw this figure like this. I can draw a figure anyway and just, because I don't know that which angle is 90. But one thing is for sure, that the slope of this line and the slope of this line should be perpendicular. Okay. Slope, either thing is that slope AB and BC is perpendicular, or it is that AC and BC is perpendicular. So that is what we need. We need the slope of all the 3 lines, and if any 2 lines ka multiplication, slope of multiplication is -1, then it is perpendicular. So we see over here, first slope AB is y2 minus y1 upon x2 minus x1, which is 4 minus of minus 2 upon minus 4 minus 4. That is 6 upon minus 8. That is 3 upon 4 equals to minus 3 upon 4. The next C is slope BC. It is again slope BC. So it will be right this way. That will be 6 minus 4 upon, this is 10 minus of minus 4, which is 2 upon 14. That is 1 upon 7. So no connection at all. Let's take out slope AC. Okay. We'll take out slope AC. So slope AC will be equal to 6 minus of minus 2 upon 10 minus 4. This is 8 upon 6. That is 4 upon 3. So now you can see that slope AB is equal to minus 3 upon 4 and slope AC is equal to 4 upon 3. So you can see M1 into M2 is minus 3 upon 4 into 4 upon 3. So that gives you equal to minus 1. Since M1 into M2 is equal to minus 1, therefore AC perpendicular to AB, therefore triangle ABC is right angle triangle. Got it? So without finding out the distances and finding out the Pythagoras theorem, we just came to know by the slopes that this line and this line. So what we got is that AB and AC. So AB and AC were perpendicular. So it was something like this. This is 90. This is A. Okay? This is A 4, minus 2. Right? This is the actual thing. That this slope and this slope, this is M1, this is M2, they are forming minus 1. Got it? So this was sum number 8. Right? We'll stop over here. The next we continue in the next video.